We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Welcome to the introduction of heat exchanger. I, Rohit Kurtarkar from Government Engineering College, Valsad, Chemical Engineering Department, would like to give you the glimpse of introduction to heat exchanger. First, we will define what is heat exchanger. The term heat exchanger encompasses all devices used to transfer energy from one fluid to another. Some examples of it are radiators, which you might have seen in trucks, vehicles like cars, or in some motorcycles. Water heaters like gas geysers, refrigeration batteries, which are used in warehouses or in storage facilities, evaporators, steam generators. Heat exchanger basically it is an equipment to exchange the heat from a hot fluid to a cold fluid without directly contact in between them. It is an indirect contact between the two fluids. Basically, each fluid has one inlet stream and one outlet stream. I hope you have understood a basic introduction what heat exchanger is. Now we will be moving to the next topic, components of heat exchanger and nomenclature of heat exchanger. Let's go to the basic components of shell and tube heat exchanger. In components, we have shell, heads, tubes or tube bundles, tube sheet, baffles, tie rods or spacers, nozzles, channel and channel cover, flanges and supports. I would like to explain you each of these with the help of diagram. Here you are looking at the shell and tube heat exchanger of name AES. You can see clearly this is a cross section of a heat exchanger where there are total 4 nozzles. First one for a shell side, then second one again one for a shell side, and this is third and fourth. 2 each for each side of a fluid. I mean shell side fluid and tube side fluid. These horizontal tubes through which the tube side fluid passes, and from these nozzles the tube side fluid enters, and from these nozzles tube side fluid exits. Similarly, for a shell side fluid, this is a nozzle for an entry of a shell side fluid, and this is the exit of a shell side. On each nozzle you will be having a connection point. Those connection points can be useful for temperature measuring devices or pressure measuring devices. And the fluid entering from this side will pass through the tubes and will again here it will take a second pass through the tube, and in this way it will exit. Over the tube you will be having baffles. Those baffles are useful for creating a turbulence in a shell side fluid, which will increase the heat transfer. And those baffles also support the tubes, and baffles are themselves supported with the help of tie rods. These tie rods are numbered with 27, and they are also known as the spacers, which maintain the space between the baffles. Also, this is a channel cover. This channel cover is a closure of the channel, and in channel you can see this is a pass partition, which is here number 31, it is given over here, which splits the tube side fluid inlet with outlet. Similarly, there are also the pass partition for shell side fluid. This is an bonnet type of a head where you can clearly see which is which is either elliptical head or torus-spherical head. Basically, this is a floating head type of an heat exchanger. Kindly observe that AES, this AES nomenclature helps to determine the type of an heat exchanger. I would like to give some more better view of a heat exchanger with an industrial example. Here you can clearly see how the heat exchanger looks from inside. This is a 3D model. These are the nozzles, I repeat, and these are the flanges which are used to connect the inlet strip, and here again the outlet strip. Okay, this is a lug which is useful for carrying or transporting from one place to another. Here you can see this is a tube sheet where the fluid enters and exits. Basically, the heat exchanger you are observing, this is a U-tube type of a heat exchanger. The support over here is a saddle support, and again same nozzles are being provided to the shell side, and cell is enclosing the tubes along with a shell side fluid. You can clearly see the fluid entering from one upper side of a tube sheet and will come out from the bottom side of a tube sheet, because here the pass partition is given. Okay, and while connecting the head with shell, there is a gasket in between them. This yellow color is said to be the gaskets, and this bunch of tubes are said to be tube bundles. And see how baffles are cut. Those cut in baffles are said to be a segmental cut baffles, which provides the passage of shell side fluid. Now we will move on to some other examples. These are some industrial examples. You can see in head how the pass partitions are being created, and this is again a similar shell and tube heat exchanger. Over right hand side, this is a Titan manufacturer's U-tube shell and tube heat exchanger. You can clearly see how the tubes are U-shaped, and here you will be having Code Design Engineers shell and tube heat exchanger, where you can see the different parts of an heat exchanger and even the different type of head. Now we will move on to the nomenclature of heat exchanger. Basically, this nomenclature helps us to identify the type of a heat exchanger it is. The nomenclature of a heat exchanger is done with the help of the TEMA standards, where TEMA is Tubular Exchanger Manufacturers Association, which has provided a standard nomenclature for describing different configurations of common shell and tube heat exchanger. TEMA's 3 simple letter nomenclature is an efficient and effective way to describe the front end head type, shell type, and rear end head type. For an example, we will have a pictorial representation. First, we will have some basic TEMA standards. On left column, you can see A, B, C, and D. These all alphabets represents front end stationary head types. These all represents front end stationary head types. Whereas this middle column E, F, G, H, J, K, X, the middle letter of the 3 alphabetical name represents the shell types, and last alphabets represents rear end head types. Okay. Now, in shell types, you can see E stands for 1 shell passes, F stands for 2 shell passes. Here, again, I would like to show you a longitudinal baffle where it splits the shell side fluid in 2 parts. Whereas G gives a split flow. In between, there is again a longitudinal baffle, but at different arrangement. Where H gives double split flow, J has divided flow, where one stream is inlet and 2 streams are outlet from a shell side. K is a Kittel type of a heat exchanger. Basically, those are boilers. X is a cross flow. Cross flow stands for a perpendicular flow direction with the tube side flows. Now we will understand this with an example. Here you can see the BEM type of an heat exchanger. And also I would like to inform you, here there are again different numbers are attached with the different parts or components of a heat exchanger. Those missing numbers in previous diagrams you might find over here, because each heat exchanger has different components. Here you will be seeing a 37. This is a bracket support. This number 14 is an expansion joint. Again, this type of a head is a conical head. So every heat exchanger comes with a different component. Now this heat exchanger is named as BEM. Okay. Now take a look at the TEMA table. Here, B stands for front end stationary head, which is a bonnet integral cover type, which is similar to the diagram. The second one was E. E stands for shell side. It means that the shell has one pass. Last one was M. Here M says that fixed tube sheet like B and stationary head. So your tube sheet is fixed over here. This is a tube sheet at which the tubes are attached, and the head is stationary. Now take another example to understand the same. This is an AEP. Now here you will be finding different types of plants, as the tube sheet may not be fixed. Or this is a floating head type of an example, which will help the expansion of a tube. This AEP will take a look at a TEMA table. Again, A stands for front end stationary head type, which is a channel and removable cover. This is a channel from where the tube side fluid enters and exits. In between you can see the clear pass partition. Similarly in B type there was a pass partition, and this is a channel cover which covers the head or a channel. Now next one was E. E stands for one shell side pass, and coming to point P, which is a rear end head type, which is again an outside packed floating head. Now this is an example of a floating head type of a heat exchanger. As I told you, which helps, it will help in expansion of a tube, but it is a packing which is done, which is prevention of a leakage. It is outside the floating head, so it is said as outside packed floating head. Here you can see the 24, which is a ring which prevents the leakage of a shell side fluid. So this is the packing which is done outside of the tube sheet. Now last one example is CFU. We will take a look in TEMA table. C is removable tube bundle only, and channel integral with tube sheet and removable cover. So here this channel is an integral part of a tube sheet. You cannot separate the channel from the tube sheet. Whereas in part A there was a flange provision which was able to be separated from the tube sheet or from a shell. So in C it is an integral part of a tube sheet, so you can't separate the channel. Again, the cover is removable. Then next word was F. F is two shell pass with longitudinal baffle. Again here you can see the longitudinal baffle which splits the shell passes in two. Last one was a U, where U stands for U type of a bundle or tube bundle, where due to this the head changes accordingly. Here you can see the head is either a toruspherical or elliptical head. So this helps again in expansion of a tube. I hope you have understood the basic diagram of an heat exchanger and components of it and nomenclature related to it. Thank you.